Our I can statements for today are, I can explain that the division of any two integers is a rational number, and I can explain that the location of a negative sign does not change the value of a rational number. Remember, by definition, a rational number can be written as a ratio of two integers, A compared to B. This means any fraction is a rational number. And one thing that we didn't mention just now in our definition, but we always want to keep it in mind, is that this B, our denominator, cannot be 0. Okay, so that's part of our rational number definition. But as long as the denominator isn't 0, any fraction is a rational number. It also means that the quotient, or the result of division, of two integers is also a rational number. Okay? Now, sometimes two integers divide evenly. In this case here, 4 divided by 2, or 4 over 2, is equivalent to 2. But what that means is that integers can be written as rationals as well. So we have done this a lot, especially when we're trying to do operations with fractions and one of our numbers is a whole number. You can write that whole number as the number over 1 because it is 8 one whole parts. Also, if integers don't divide evenly, they can be written as decimals. So what this means is most decimals are rationals too. Next week, we're going to learn in more detail how to tell if a decimal is a rational number. So that's not going to be the focus of today's lesson, but just know that if you can write it as a fraction, then it is a rational number. So try these quick check problems on your own. Are they rational numbers, and how do you know? Pause the video to think about it and start it up when you're ready for an answer. All right, let's see if you got it right. Okay, for number 3, 12 divided by 3 is a rational number because division of any two integers is rational. We could rewrite that as 12 over 3. It's in fraction form, so we know that it's a rational number. Also, 12 divided by 3 is 4, and we can write any whole number as a fraction by writing it over 1. So, in both cases, we know that 12 divided by 3 is a rational number. Let's take a look at number 4. What do you think? Okay. It is a rational number because the division of any two integers is a rational number. So if you can write it as a fraction, it's a rational number. Okay? So don't get this confused with a mixed number. This is an improper fraction, not a mixed number, but it's still a rational number. All right, these next two problems might seem overly simple, but they're here to illustrate an important principle. So the first thing you're going to do is find the quotient. So you're going to divide the two numbers shown, and then you're going to plot the quotient, or the result, on the number line. Okay, try this one on your own, pause it until you're ready, and then start it back up when you're ready to check. All right, for number 5, we could rewrite negative 6 divided by 3 as negative 6 over 3, and if you didn't do this part, that's fine, but I included it because it'll be important to compare these two examples, okay? But the quotient is negative 2. We plot it here on the number line. Now let's take a look at our next example. Okay, in this case, 6 divided by negative 3 would be written this way in fraction form, 6 over negative 3, but it still equals negative 2. So when we plot it on the number line, it's negative 2. So notice, the value of our answer doesn't change whether the negative sign is on the top or the bottom of the fraction. Okay, so in both cases, as long as there's one negative, it doesn't matter if the negative is in the top or the bottom, they are equivalent fractions. All right, try these problems on your own. I want you to try 7 through 9, and there's also the bonus problem you can try if you're feeling super confident with this concept. So let's do number 7. True or false? Negative 2/4 is equivalent to 2 negative fourths. Well, they're the same denominator and the same numerator. The only difference is where the negative is placed. And there's just one negative in both examples. So this is true. This is true. Try 8 and 9 on your own. Pause the video until you're ready to move on. All right, let's take a look at number 8. We have a 1 on the top in both fractions. We have a 3 on the bottom in both fractions. And we have 1 negative on top, 1 negative on bottom. That means that they are true because it doesn't change the value of the fraction if the negative changes places. And number 9, true or false? So I have a negative on the top. I have 1s on the top. I have a negative out front, and I have 6s on the bottom. So let's think about this. Is negative 1 divided by 6 the same as negative 1 divided by 6? This is true. I'll go ahead and erase that so that you can see it a little bit more clearly. They have all the same pieces, the same number of negatives, so these are true. Okay, let's take a look at the bonus problem here. Now, I only have 1 negative and 1 negative, so that doesn't change the value. Now I need to ask myself, is 2/4 equivalent to 1/2? Yes, it is true. So just because they don't look the same doesn't mean that they can't have equivalent values. We can simplify 2/4 to be 1/2. So this is true. So our tip to remember is that changing the location of a negative in a rational number doesn't change its value. The negative could be on the top, it could be on the bottom, it could be out front. We could also change it to a decimal, and they all still have the same value on the number line. There's one more example that we didn't get to in our notes for today, but what happens if we see something like this? They both have a 3 on the top and a 4 on the bottom, but in this case, I have 1 negative, and in this case, I have 2 negatives. And remember, negative divided by negative becomes a positive. So negative 3/4 is not equal to positive 3/4. Okay? But let's take a look at this example. Is negative 3 over negative 4 equivalent to positive 3/4? Yes. This is true. We just said negative divided by negative becomes positive, so these two are equivalent. So those are some bonus examples of equivalencies between negatives and positives. Remember, you can rewind, you can watch the video as many times as you need to, pause when you need to make sure that you're understanding these concepts.